you don't win, there's actually a problem.
Yeah.
All right, good.
Wouldn't it be the worst though? Taken in the
All right, we're
past
getting started. A couple of seconds. Can someone on the Zoom call please talk?
I think what's worse,
Hi.
failing a legit open.
Thank you, Amy. Yeah. All right, here we go. All right, welcome everyone to Space City Rocketry's General Meeting on November 2nd, 2021. For the agenda today, we're gonna be going upcoming events, shout outs, our structures Kahoot, sub-team updates, and then a lesson over analysis by Ravi. And then at the end, we'll have some room for questions. So for upcoming events, as we've been talking about over the last few weeks, we have the COTS/Zenith PDR Friday, November the 19th at 7 p.m. The room is to be determined, but we'll know in the next couple of days. Same for the SRAD PDR, that will be Friday, November 20th at 2 p.m. Same thing, same situation with the room. But one thing I want to emphasize this week is AIAA's third general meeting. That's this Thursday, November 4th at 7:30 p.m. in CBB 122. So very close to what we have our general meetings for SCR. There will be blood.
I'm sorry. Today I reserved 122 for both PDRs, so I assume that should go through.
Okay, words from Garrett, or update from Garrett. Thank you, Garrett. He reserved CBB 122 for both PDRs. So thank you very much. He's blushing right now. But yeah, for the IAA meeting tomorrow, there will be food and a guest speaker. It's gonna be great. You know, we only have 3 of these a semester. So please make sure to show up. There's gonna be a lot going on. And then the alumni panel, Wednesday, November 17th at 7 p.m. We'll have more info about that in the upcoming week. So for shout outs, we have a few shout outs this week. We wanna give a shout out to Bailey, Stephanie, and Christian from Recovery for consistently joining meetings, going to the lab and working really hard. And Alex Blick, last year's chief engineer. Yeah, last year's chief engineer for putting in work as a recovery member.
Oh, man.
Yeah. Nikolai and Christian from Analysis for putting together a presentation about rocket stability for their meeting. It was great. And then also the SCR whiteboard. It's just chilling at the lab. Here's some pictures.
Wow.
Yeah. Yeah, it's the same picture, but all right. Now Goose is gonna take over. Talk about Triple E membership.
Okay, so thank you for having me. Like last week, I'll say it again just for everybody who wasn't able to catch it last week. The competition this year is going to be hosted by Triple E, or it's going to be hosted using Triple E rules. Who is or what is Triple E? Triple E is the rocketry association that controls, or I guess progresses all of amateur level rocketry in the United States. And so why do we want to be part of the Triple E or anything like that for the competition? Well, like I mentioned, the competition is going to be run using Triple E rules. So Triple E rules say that we need to be at least an L1 to be out on the launch pads or anything like that. So to compete at the competition, if you want to go and participate with us and everything like that, then you will need your Triple E certification, at least to an L1. How do you get your membership? There is the QR code right there to be able to fill that out and get your membership. For students anywhere from I think 18 to 24 is only $10. So that's, you know, it's a bargain. There's a lot of cool stuff there. And then how do you get your first certification? There's info on the website where you can, you know, see what the requirements are and everything. You can do basic stuff like, you know, look up a kit on apogeerockets.com, and they have cool little things where you can make your own rocket. It's pretty simple. And if you need any more info on how to get your rocket or your L1 certification, you can reach out to the Hobby Rocketry team. they have a lot of cool info on that. And so I will hand it back to Irvin.
And I will hand it to Haley. Come up here so you can do the Kahoot. Structures Kahoot. All right. Somebody here in person printed the slides.
I
and
did
took
not print out the
notes.
slides, all right? I'm not that big, but I took
So
notes.
I don't know if we should consider that cheating.
Taking notes?
Taking
notes.
notes.
Is it open note?
You never know.
Is it open notes? Is the
Hey,
question.
that's academic
I mean,
honesty.
Not gonna lie, like, I didn't write that much. Like, it's like 3 points.
All right,
It's only like
sure.
3 pages. It's not
Yeah,
that
I'll be the
much.
judge now.
That's one now.
Yeah, we're checking his notes right now.
I think open notes is fair. Yeah. Sorry, I paid attention.
All right, there we go. Can everyone see the?
Yeah, we'll do a $5 fee for notes. Wait, is there a prize?
Hmm?
Nah, no prizes to use notes.
There we go. Sorry. Yeah.
There we go.
Yeah, what's with this music?
Well, Halloween
It's not
just
Halloween
ended.
anymore.
Yeah, guys, it's Christmas time. Dude, if a structures member doesn't win, I'm gonna be disappointed. Gustavo's not allowed to play. Neither is Robbie. Since it's Frankie cheating off his notes. No. Previous leads of structures can't play.
But they cannot win. How about that?
What happens when you do? But then they're taking away a winning spot from someone else.
This is true.
Well, if that's their in the top 3. What are the odds? Top 3 is all leads. We care about the winner, right? Boy, he can't play. You definitely cheat.
Now they can get off.
I'm not playing this.
Oh, okay.
All right, get this out.
All right.
Wait,
Hey, who's this? What's this?
Wait.
hey, somebody's speaking facts.
What? Do you get a large nose?
Can we not talk about large notes? Wait, what happened? Hey, there's
All right, getting started.
On the thing.
Oh, yeah.
That talks about, if you don't like your notes, and we have a phone number.
I think the best part about me is
All right. So, what material will the airframe of Zenith be? This needs to move. This needs to go elsewhere.
you're in. There you go.
Better see Frankie first.
No, I was low tier. I'm not a bad angle.
Pila?
Oh, is it?
Huh? Paper mache? I think that's a great idea.
Much stronger.
Can I redo that?
Hey, what is this scoreboard? Where? At what Mach speed do most materials for airframes become insufficient? Damn, Frankie, it's on your notes and everything.
Bro, I mean, like it's perfect, but like
From experience.
I know for a fact Frankie does not take fluids.
oh, yeah, boy.
Yeah, boys.
We got Alexander in first.
Dude,
Is that Lynn? Is that you? LT? I'll take all teams out. Frankie, structures best, and Christian.
Let's go.
All right, where is the root chord?
The root. Bro, that was not on the power. I don't know. I don't play guitar here. You get this right. How am I supposed to look forward to play? I think
It's a G minor.
G minor.
Oh, your boy.
All right, we got structures best in first. Makes sense. Your boy Frankie, Christian, Alexander, and well, moving.
Why did you say it?
Where is the semi-span?
Six.
It's at least 9. 55. I got it correct.
Frankie.
Frankie, it was over here in first.
That wasn't even in my notes.
I don't
It wasn't on the PowerPoint.
That's got Frankie. You have it written on your notes.
No, I don't have the diagram, bro. I have no idea what that is.
Afterwards.
Oh, come on now.
Easy money.
Easy money. Easy money.
How was it? Guess. Yeah, what was it?
At least 12 minutes.
What? It has to be at 115.
There has to be at least one body caliber.
What is the count?
You'll find out at the analysis.
Oh, really?
All right.
I'm probably gonna win something in my life.
What does MMM stand for?
Mini motor mod.
More money.
We have a
Single-handedly.
Yeah, that was
I live by look at everything.
Too slow.
all right. Carbon fiber blocks radio waves. Is it true or false?
God.
I'm gonna show the hard thing.
Oh.
Why does it block radio waves?
Yeah, why does it?
I didn't ask you.
Hey.
Oh, no.
You're not gonna get like that.
All right. This is the most important question right here.
No, I
had to do it for the point.
Wait, did that count? 16 people have no. Does that count?
Yeah.
Well.
Oh, man. I had to do it for the point.
Hey, here we go. Nah, I didn't count.
Alexander.
No!
No! Just because I was slow on the first one. I'm done with this.
Congrats to our winners.
There's only one winner.
Did you see any instructions numbers on the?
Oh, man.
You're adding your own team. That's different.
Too bad, Frankie. You were almost there. Not quite there.
Bro,
Next time.
you're not first or last.
Next time. All right, next up. Oh, wait, hold up. Let me. Yeah, I need to mute the. I'm about to just leave it. I'm leaving it. I kind of like the music. But... Whoa, 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 whoa. Why is it so hard? All right, here we go. Sub-team updates. Tala. 30K proportion.
How's my audio?
Great.
Okay, so for 30K propulsion, as far as the new test stand, we did do our preliminary sub-team presentations. So we split our team up into configuration, electronics, and materials to make the brainstorming a bit easier. So yeah, everyone in that sub team gave their little presentation, and there's like some of the sample slides to the right there. And we did have great feedback from the leads, so that went well. And then as far as the capstone test stand, we have still, well, I mean, we're still helping out SRAD to drill and cap the test stand rails. I think when we were there last Thursday, we got 2 rails done. But But yeah, that's as far as 30K propulsion goes.
Thank you, Tala. Now, analysis, Robbie.
Thank you. So for analysis this past week, on the design team side, we had our rocket stability presentation by Christian and Nikolai. They did a great job. Definitely, if you want to learn more about that, come and watch the recording. The Oberon MMM FEA, a little bit of a shift in our priorities for the PDR, but we're performing tutorials from the book and also meeting with Gustavo, our chief engineer, on Friday. And the shift I was talking about was with our 3 Zenith MMM FEAs. We're going to push it back to the post PDR. We want to be able to do it right and correct. And then as it's something that is mission critical, we want to do it right and give us some good practice with the Oberon MMM FEA first. And then they're also working on the Zenith CAD just to start prototyping a full CAD for Zenith, which will make the formal CAD later on down the line much easier. With the validation team, we're still working on the nose cone analysis. I made corrections to the open rocket control configuration due to some errors we had in there, and updated the simulations off that and wrote most of the report. We'll also be adding another section of analysis due to some advice Randy gave us. And then the Zenith Open Rocket and RockSim, I want to make sure that we're focused on designing for a good stability margin and weight. And then the PDR documentation just coming up and getting that report written so we can send it out. Thank you.
Robbie. Now V with avionics.
Right. So this week we did a lot of electronics work. So we got the TNZ up and running with multiple sensors, which was really cool to see. Tuned all of our sensors correctly so we can start going to collect some of those values. We're going to start testing those in a car, especially the acceleration values, so that we can compare like the acceleration that we're receiving in the car versus the acceleration that the boards are reading, just to kind of get some information to make sure that our sensors are reading as accurately as they can. Completed just a trade study for the ground station. So the ground station need to choose a main controller. So we've completed that trade study. We're going to start, putting together a parts list officially. Start to design components for the ground station display. One of the big things that we have for our ground station is we want to have a display this year to display useful information and potentially the 3D orientation of a rocket. So we need to start choosing what displays we want to be using. Got the multiplexer up and working. The BMP 390 is reading as well as the LSM X06. And currently we are working on denoting states for the flight computer for this next week. So that will kind of allow us to interpret where the rocket is going to be at and just kind of useful information from there and, like how to respond accordingly. And then there's a picture of the BMP 390 on the side there.
Now structures.
So we're still in the process of working on the nose cone trade study, which we'll go ahead and finish up once we can go ahead and analysis has the chance to finish up some of the drag calculations. And we've also decided on the 3 MM options that we want to go ahead and proceed with, which is capstones, Ozzy's design, and Gustavo's design. So good job.
And then recovery. Oh, yeah.
So for recovery, for the separation crew, actually today during the lab, we finished the CO2 decision, and there's the decision matrix. So at least for the CO2 system, the decision has been made with the Raptor system. And then for the landing crew, the parachute size and snatch force calculator is still in the process of being done. You can see there, it's kind of a mess on the bottom there, but we are working on it, and the hope is that we'll finish it this week.
Which brings us to our upcoming, the CO2 system decision, as I said, has been done already. The calculator also needs to be completed. And then upcoming for, I guess, next week would be looking into the black powder system for the separation crew and looking at tender descenders for the landing crew. And that is it for recovery.
We were standing up for Carlos. Thank you. Now, Ozzy.
Yeah, can y'all hear me?
Yeah, we can hear you.
All right, awesome. Give me 1 second. All right, so this week we actually don't have too many news. We're just gonna continue working on the test stand, and it looks like we're getting about like 80–90% there. So looking forward to that this Thursday. And also the hybrid motor capstone team needs our help with just some electronics and gearbox stuff for the valve control system on the hybrid motor. And that's all we got for this week.
All right, thank you, Ozzy. And now, rocket lesson. So today we're gonna have a lesson with analysis. Rob is gonna come up here and go over his slides. I know it says the following week, the 9th in here, but we've made a decision that we will not have a general meeting next Tuesday at 7 p.m. Instead, we're just gonna meet and start working on the PDR report for both COTS and SRAD. So it will be the week after that that we're gonna have the recovery lesson. And then that's when we will also have the analysis Kahoot. So basically a week from what it says. So, all right, come on up, Robbie. I'm excited. Robbie has been hyping up this lesson all day. So high expectations for this.
All right, hello, everyone. Analysis by tradition is a little bit of a different lesson. I think we're a broad encompassing subteam and a new one at that. So what is analysis? Start off, I think we're more of a consulting subteam. So Kowalski, analysis, and we kind of just spit out an FEA. That's pretty much what we do. No, but seriously, before we start to look at what is analysis really, we need to ask ourselves first, what is engineering? Engineering is the application of scientific and technical skills to a planning process. A special shout out to Dr. Chang for these notes from Mech Design. I still have it, so this is it. It is science-based analysis and technical skills in the planning process that to provide confidence in the execution of the design. So then that leads us to the question, what makes a quality design? So there are 3 pillars to design acceptance. Number 1 being the needs of the design. Number 2 being the risks of the design. And number 3, where analysis comes in, is the credibility of the design. Now that leads us to what is analysis? Analysis, our main goal is to provide validation of design. Engineering project plans require more attention to physical, quantifiable traits and performance, and quality and credibility of technical evidence and decision-making. So this is where we come in with the whole engineering project process and timeline. So we operate through these, I think 3 bubbles is the best way to put it. The first being focused on computational mechanics, or CAD, FEA, and CFD. The next being apogee simulations, or OpenRocket and RockSim. And the last being mathematical models. So we have our 3 bubbles here. And today I will be talking about CAD, FEA, open rocket in particular, and rocket stability. So what is CAD? CAD stands for Computer Aided Design. It is the use of computers to aid in the creation, modification, analysis, or optimization of a design. Some examples of CAD softwares include AutoCAD and SolidWorks, as I'm sure a lot of us have used in class or for side projects, and the Siemens software, which we're very proud of, Siemens NX. Now within SCR, CAD, we're going to use it to create a database of past, current, and potential designs. And they also operate as inputs for our FEA and CFD analyses. So there's some figures of some CAD models we have. Now, what is FEA? FEA stands for Finite Element Analysis. It is the process of simulating the behavior of a part or assembly under given conditions so that it can be assessed using the finite element method, or FEM. I took this graphic from a YouTube video. I thought it explained the process pretty well. But generally, you have your problem that you want to solve. And the finite element method essentially breaks the problem up into a bunch of smaller problems, a finite number of problems, you could say, solves those problems individually, and then reassembles it into a whole solution. So there's some FEAs we've done a little bit of. Now more about the process of an FEA. The first step is to define the problem. What do you want to know and what do you wish to gain? The next is to create a model. So as I mentioned with our CAD software, you want to create as accurate of a representation of the object or the system as you can. Next, you want to define the loads and constraints and mesh the model. So here is where you define the forces that your system will undergo and also identify points at which your system will be constrained. Next, you want to define the analysis. So what kind of analysis do you want to perform? What data are you looking to gain from the simulation? And then you submit it to the solver and gather the post-process data. You submit it for simulation, and after the simulation, you can look at your results and conclude from there. Now, how does that apply to us? Well, number one, we want to learn where FEA is necessary. You know, we're not just going to go out and perform an FEA for every problem that we want to encounter. So we want to learn where to pick our spots and how it can be helpful. Really understand the modes of failure and the paths to failure. I think that's extremely relevant when you're building a rocket and you want to try and think about more of what will make my rocket fail than what will make it succeed. So you can design for failure. You want to identify, or you want to learn how to identify and apply potential analyses, really just getting our hands on with the software. And most importantly, really is learning the entire process. I think it's an extremely marketable skill to have as an engineer, and within the aerospace industry, it's extremely important. So that's kind of why we were rebranded, and that's why FEA is a big focus for us. And a huge bonus is that the spaceport judges love seeing this, especially with building a rocket from scratch. We don't have, like last year with Oberon, we had parts, we knew they were flight proven, we knew they were going to fly at the end of the day. But here we really don't know. So FEA can help us bridge that gap and give us some confidence in our design. Oh, I forgot to animate this. Okay. But now moving on to rocket stability. So essentially, a rocket can be described as stable, overstable, or understable during flight. And the different factors that contribute to this determination are center of gravity, center of pressure, and also the diameter of the rocket. And that's called the rocket stability margin. So the center of pressure and center of gravity. Starting with the center of pressure, this is the point on the rocket at which all aerodynamic forces, pretty much lift and drag, will act on the rocket. This must be located behind the center of gravity and also above the fins. And in the next slide, I'll talk a little bit more about why that is the case. In center of gravity, or CG, is the average location of the rocket's weight, pretty much the center of the mass of a rocket. You can find it by balancing the rocket on an angle iron, which we've done in the past, or a ruler to try and see where its midpoint is. And it is also the point at which the rocket rotates about itself during flight. So now stability margin. This is used to relate the distance between the center of pressure and center of gravity, which is measured in calibers. One caliber is defined as one body diameter of your rocket. So zenith's diameter or body diameter is 6 inches. So one caliber for zenith is also 6 inches. If your stability margin is greater than 1, you are considered to have a stable rocket. But per the Spaceport America Cup design regulations, nominal stability is around 1.5 to 2. And if you're greater than 2, you're generally considered overstable. So stability margin is found by taking the center of pressure location, subtracting the center of gravity location, and dividing that by the body tube diameter. Center of pressure is behind the center of gravity. So you measure these locations, assuming the tip of the nose cone is at 0 and your fins or your endpoint is however long your rocket is. Also, something really interesting is that, as I explained on the last slide, the center of gravity is the point at which your rocket rotates about itself. So also on the last slide, center of pressure is where all aerodynamic forces act. So this stability margin for my mechies in here creates a moment arm of which create the lift and drag act as counterclockwise torques and moments about the center of gravity. And that is the restoring force that keeps your rocket stable. It's kind of interesting. If the wind comes and hits your rocket off its flight direction, the lift and drag of the rocket, if your stability margin is nominal, will restore your flight path and keep it generally in a straight direction of which you launched. That's it for me. Thank you for listening. And yes, sir.
I don't see anything wrong with it.
That's a good question. So if you are overstable, that means your center of gravity is going to be far in front of your center of pressure. So your moment arm is going to be very large. So when you have a small force of wind or a small gust of wind, the little bit that it knocks it off, it's going to overcompensate for trying to get it back. The restoring force, because your moment arm is too large, is going to be too big. So you'll kind of, what's the word, shuttlecock or like weathercock, there you go. Yeah.
What if you're understable?
Understable will mean that it will just be subject to the forces of the wind. So if your wind pushes you off, it won't have enough force to restore itself. Yeah. Any other questions?
Does the center of pressure kind of change a little bit as it rotates? Maybe not too much, but.
Not too much, but that actually brings up a good point that I kind of forgot to mention. Your center of gravity does change throughout flight because as we're using a solid motor, as the fuel burns, we're losing more mass of the motor. So your center of gravity shifts up. So your max stability is at apogee or after your burn time.
Any other questions? How do you calculate your center of pressure?
So traditionally, or with SCR, we've used OpenRocket to calculate it. You can go and look at the OpenRocket documentation because it is open source. They use equations called the Barrowman's equations, which are pretty complex. We've given a look at them, and I think they're a bunch of differential equations that they try and determine. There are some simpler ways, I think, to calculate it for smaller rockets, but it's obviously going to be by hand and trying to calculate everything. So it's kind of a pain.
Essentially, it's just like the average location of all the surface area. So by
If you can
you're
hear me,
introducing the surface area.
For those on Zoom, if you can hear, Gustavo said it's the average location of the surface area.
Thank you, Robbie. All right, let's just take that. All right, does anyone have any questions, any general questions about the team? About any of upcoming events? Next week, Tuesday at 7 p.m., we will not have a general meeting. However, if you want to help out with the PDR report, we will still be meeting here. It will mostly be the leads, Goose and I, who will be working on that and all the documentation for that. So if you want to learn what it entails to write a report, please just reach out to your leads, help out, and we'll be here just chilling, writing.
I would actually encourage anybody to come. Actually, it's encouraging.
Yeah, like, please come. Basically, as Gustavo just said, like, sure, there's no general meeting, but we would encourage everyone to come. You can ask questions about the other sub teams. You will be able to see like hands-on, like writing, basically what I just said. But yeah, please still show up if you can. And then last few things, this Thursday, 7:30 p.m. CBB 122 AIAA third general meeting. It's gonna be great. They're always fun. There will be food, so that's always a plus. And then for the PDRs, mark your calendars, November 19th at 7 p.m. It's a Friday, and November 20th, Saturday at 2 p.m. We're gonna have professors, alumni, and it's gonna be feedback of whatever we have this year for Zenith. So we will get roasted, we will get good feedback. They're gonna criticize and give us positive feedback on our decisions. So please come, it's gonna be great. That's it. I hope you enjoy the rest of your week, and I'll see you at the lab and anywhere else.